Hi students, this is AJ sir. Let's study 10th standard ICSE Math chapter 24A and 24B. Measures of central tendency, mean. Exercise 24A, mean. Simply speaking, it means average. So, question 4A, find the mean of 7, 11, 6, 5 and 6. How do we take an average? We will total them and divide it by the number of quantities. Now, cancel question 1 and 3, they are very easy. Mean is equal to summation. This sign is called the sigma sign, which is an operation called summation. That is the total of all the numbers. Summation of x. X is the unknown variable. Each of these can be x. x1, x2, x3, x4, x5. So this simply means total all the values of x upon n. Here n means the total number of quantities or total number of observations. That is 1, 2, 3, 4, 5 observations are there. 5 numbers are there. So divided by 5. So what is the average we get? 7. So that's the mean, or that's the average of all these numbers. The data given here was untabulated. Tabulated data would have looked something like this. Now 4b, if each number given in A, that is 7, 11, 6, 5, 6, is diminished by 2, that we subtract 2 from each of these numbers and we'll get 5 new numbers. What is the new value of the mean? Well, we need not calculate everything all over again. If each of the number is subtracted by 2, then the new mean will also be the original mean minus 2. So we can directly write the answer as 5. Now for a tabulated data, it can either be grouped or ungrouped. This is ungrouped. There are no class intervals. If the sum was like this, which we'll do in the next exercise, we have class intervals. This is called grouping. 0 to 10, 10 to 20, 20 to 30 and so on. So let's understand how to solve ungrouped tabulated data and find the mean of this. The ages of 40 students are given in the following table. The frequency, if you add them, will definitely be 40. It means that out of all the students, there were 2 students in the range of 12 years age, 4 students were 13 years old, 6 students were 14 years old, 9 were 15 years old, 8 of them were 16 years old, 7 of them were 17 years old, and only 4 of them were 18 years old. So totally there were 40 students. So the question is, what is the average age of all the students, or what is the mean age of all the students? Now you may think that the extreme values are 12 and 18. So the mean could be 15 perhaps. That's the average of 12 and 18. But that would be inaccurate, because the number of students for each age is different. So we'll have to take that also into consideration while calculating the mean. In such a case, the formula for mean is summation of f into x upon summation of f. So let's see how to solve this. First, we make a table. We have all the x values here and the f values also mentioned. We have to copy that. F is a frequency. That is a number of students for each age. Remember, frequency never has any units. Now we have to multiply them. 12 into 2, 24. 13 into 4, 52, and so on. We'll total f, that's summation of all f, 40, obviously, because there are 40 students given in the question. And we have to total all this. That's summation of fx. That's 614. And now we can use the formula mean is equal to summation of fx upon summation of f, which gives us 15.35 years. It's compulsory to write the unit in the end if it is there in the question, otherwise you lose marks. So notice how the answer was not 15, rather 15.35. It could have very well have been 14.35 if the frequency numbers were different. So such measurements of central tendency, that is mean, median and mode, help statisticians, helps businessmen, economists, engineers in their work. In this chapter, we will simply study how the formulae work and how the mean, median, mode are calculated. Their practical applications will be taught only in higher standards. But rest assured that this chapter is very useful in many fields and careers. Now let's do question 8. Here the mean is already given. If 69.5 is the mean of these sets of numbers, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 quantities are given. Out of that, 1 is a missing value. Find the value of x. So again, it's non-tabulated data, so that's a straightforward sum. Mean is nothing but add all the numbers and divide it by the number of quantities, you'll get the mean. But mean is already given. And if you add all the quantities, we get 619 plus x. We can't add that x, of course, to it. It will have to be written like this. Upon 10, that is the value of n. 10 goes up, that becomes 695. Shift this, becomes subtraction. So we get the value of x as 76. That's the missing value in that range. Note how here the numbers are not arranged in ascending or descending order. So while finding mean, it's not necessary to arrange it in ascending or descending order. Although in tabulated data, it's advisable to make sure that they are in ascending order. Although it won't make a difference, but it is presented well this way. Now let's do question number 10. Again, it's tabulated data. The wages per day are given, 50 rupees per day, 60 rupees per day. It's quite less, but that's the reality. And number of workers are mentioned, which means that how many workers are getting 80 rupees per day? 12 workers. Now first, let's calculate the mean wage correct to the nearest rupee. So we'll have to round off if we get an answer in decimal. So we'll create a table, x values, f values, and fx multiplication. We'll do the summation of f, summation of fx, and mean is the division of the two. We'll get the answer to the nearest rupee. Now, Roman number 1, if the number of workers in each category is doubled, then what will be the new wage? Well, if the number of workers, that is the frequency changes, it's doubled, all of them are doubled, that does not affect the new mean, because mean that we got is in rupees. So only if these wages which are in rupees are changed will it affect the mean. Or if the frequency values were changed asymmetrically, like only this was changed and only this was changed, it would have affected. But if all the frequency values are exactly doubled, that won't make a difference, because then this will also be doubled and this will also be doubled. So when you divide them, we'll get the same answer. So when the frequency is doubled, the new mean is still rupees 80. But Roman number 2, what if the wages per day in each category are increased by 60%? If the wages are increased, all of them are increased by 60%, then the new wage will also be increased. The mean wage will also be increased by 60%. So the new mean will be the original mean plus 60% of that. That's 80 plus 60% of 80, which is 48. So 80 plus 48 gives you 128. I solve it like this. If they say 60% increased, that means the new mean is 160% of the original mean. So I do it in a shortcut method like this. You can solve it the way you are comfortable with. In Roman number 3, the number of workers is doubled. Well, that is insignificant. That doesn't matter to us. And the wages per day are reduced by 40%. Now, that will affect the new mean. It is reduced by 40% means you can say the new mean will also be the original mean minus 40% of the original mean. That is 80 minus 40% of 80. Or you can simply say 60% of the original mean. So we get the answer as 48. Don't forget to write rupees. There you lost half mark. Next, the 13th sum. In this table, the summation of f, that is addition of this, is given as 200. By the way, two variables are missing, f1 and f2. And the mean is also given. So we have to find the two missing variables. Because two data are given, we'll be using the formula to get two equations in two variables, and then we'll solve them simultaneously to get the values of f1 and f2. So we'll make a table. First of all, the summation of f is nothing but f1 plus f2 plus 86 if you add the numbers. And summation of fx, so first of all you have to multiply. 0 into 46 is 0. 50 into f1 is 50 f1, 100 f2, this into this is 3750, and so on. And then add the numbers, which is 7000, and 50 f1 and 100 f2 cannot be added to that. They're unlike terms, so we'll keep it as it is. Now, the summation of f we got is this, but as per the question, the summation of f is 200. That means f1 plus f2 plus 86 is 200. So that's how we get our equation number 1, f1 plus f2, 114. Let's focus on this now. We know that the mean is summation of fx upon summation of f for tabulated data, and that too ungrouped. But the mean is already given, it's 73. And the summation of fx we found out was this. And the summation of f is already given, it's 200. So again, we get an equation in two variables. Cross multiply, this goes up, the number is subtracted, and finally we get this. Can we simplify it? Yes, we can divide the whole equation by 50, and we get the simplest form of an equation. So we had equation number 1. This is the second equation. Let's simultaneously solve them to get the values of f1 and f2. You can use any method. You can substitute the value of f1 from equation 1 into this. I'm going to use the elimination method. So I multiplied equation 1 by 2 so that 2f2 and 2f2 are similar. When I subtract it, this disappears and I directly get the value of f1 as 76. And then I substitute this in equation number 1. I get the value of f2 as 38. So you can even box these answers so that the checker finds it easy to check. Presentation matters. Now the 14th sum. Again, find the mean nearest to the whole number by using step deviation method. Now that's something new. So for tabulated data, we have three methods of finding the mean. The direct method, which we have already studied, simple. Then we have the shortcut method, and we have the step deviation method. If we would use the direct method for 14th sum, they would still get the right answer. But it would be a bit inconvenient because the numbers are quite big. I mean 20 into 67, 25 into 72, 30 into 45. You'll get the numbers in thousands, and then you have to add all of them so much. If you want to avoid dealing with big numbers, then you have to use either the shortcut method or the step deviation method. In the question, they will mention which method to use. Otherwise, you can use any method you want to, and in that case, you will prefer the direct method. So there are additional steps in the step deviation method, so pay attention. We have many columns here, 1, 2, 3, 4, 5 columns. So we've written the values of x and f. We won't do xf directly. No. First, we will have an assumed mean, which is somewhere between the extreme points 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So we can assume 30 to be the assumed mean. So I have 1, 2, 3, 4 numbers below it, 1, 2, 3, 4, 5 numbers above it. That's okay. So the choice was between 25 and 30. They are the numbers in the middle here. In that case, go for the higher number always. So the assumed mean is 30. Also, find out the value of I. I is nothing but the class width, or you can say the difference between any two numbers. 10 minus 5 is 5, 15 minus 10 is 5. See, the difference is always 5. It has to be symmetrical in the tabulated data. Definitely it would be. So from x I got the value of a and I. Fine. Now step number 1, find the deviation. The deviation is that how different is this number from the assumed mean. This is the assumed mean. We are assuming that 30 is the mean, 30 is the average, but that's not true. I'm sure it will be either more than 30 or less than 30 because the frequencies are so different. So 5 and 30, x minus a is the formula we will use everywhere. What is 5 minus 30? Minus 25. What is 10 minus 30? Minus 20, and so on. Here 30 minus 30, 0. Notice that even here the difference is 5 everywhere. That has to be. Next step, after finding the deviation, we will find t, that is the reduced deviation. The formula for t is d upon I. Whatever deviation you got, you divided by I, that is 5. So you are reducing it to smaller numbers. Minus 25 upon 5, minus 5. Minus 5 upon 5, minus 1. 0 upon 5, 0 of course. See now, it's so small. The numbers have become so small. We started with big numbers and the multiplication would have been tedious, but we reduced it to the bare minimum. And now, instead of doing f into x, we will do f into t. That's the whole point. Because now we are dealing with very small numbers and addition also becomes easy. But please note, there are negative numbers involved here. So while adding, you will have to keep it in mind. This will be a negative total, this will be a positive total, and clearly the negative numbers are bigger, so the final answer is negative. I hope you all know addition to subtraction. If we wouldn't have done all this, if we would have directly done the direct method x into f, then we would have got big numbers and it would have gone into thousands and 10,000s or even more. And it will be difficult for us to use the formula later on. So although this is longer, in the end, the calculation will be simpler. And of course, in the question they have mentioned step deviation method, so we have no choice, we have to use this method. Step deviation. So now what is the formula of mean? Well, it's assumed mean plus summation of ft upon summation of f into I. So learn this formula. This is used only for step deviation method. Let's substitute all the values. A is 30, this is minus 598, this is 384, and this is 5. And then we'll get a negative answer out here. Subtract it, you get 22.21. But they said correct to the nearest whole number, so round off. Of course, if this was 22.5 or 6, then the answer would have been 23. Next, the 15 sum. So again, it's a tabulated data. They want the answer correct up to 1 decimal place, and this time they've asked us to use the shortcut method. So just like the step deviation method, the shortcut method is a little longer than the direct method. We call it shortcut because it is shorter than the step deviation method. What was the direct method? Summation of fx upon summation of f. Simple. In the shortcut method, the formula is mean is equal to the assumed mean plus summation of fd upon summation of f. And what was the step deviation formula? It was the longest of all. Assumed mean plus summation of ft upon summation of f into I. And there were 5 columns. But here there are only 4 columns. That's why this is called shortcut. Yeah, you would say that in a direct method there were only 3 columns. But then that's useful for small numbers. This can be used even for big numbers. So what are the 4 columns? Well, same as the previous sum, we will first get an assumed mean. Let's assume it's 45, the middle number, 3 up and 3 down, so no confusion there. Frequency, yeah, we won't do fx, we will do fd, where d is a deviation, and you know deviation formula is x minus a. What is 40 minus 45? Minus 5. Always the top numbers have to be negative, obviously. 41 minus 45, minus 4, and so on. So we get smaller numbers, so that when we do f into d, we don't have to deal with huge numbers. Just imagine 38 into 43, that's such a headache. But 38 into minus 2, that's easier to solve. fd. Notice how we didn't have that 5th column called t in the step deviation method. That's why this is a shorter method. So we do a summation of all this. Keep in mind there are some numbers negative, and there has to be a 0 obviously in each and every sum like this. And then substitute the values here, get the answer, and round off to the 1 decimal place, which is 44.6. In exercise 24b, cancel the first sum, also cancel 2.2, 3.2. This exercise is similar to the previous exercise. The only difference is that here we have only tabulated data and they're all grouped. We have class intervals. So that's the only difference. Otherwise the formulae and the method is the same. Let's start with 2.1. The wages have been given and we have to find the mean by the direct method. Direct method formula, we know it's delta fx upon delta f. Now delta f is just a summation of all the frequencies, that is coming to be 80, that's fine. But if they have given class intervals, then how can we get the value of x? We have 2 numbers here. If I have to find f into x, what do I multiply the f with? So in such sums, we have to find out the value of x first, which is nothing but the midpoint, the class mark as it is called. So what's the midpoint of 50 and 55? The class mark, what is the number between them? 52.5. How? Well, just add them and divide by 2. Which number is between these two? 57.5, and so on. So that's how we get the value of x. And once we do that, it becomes like the usual sum where we find fx. Oh, we have to deal with big numbers here, and decimals also required. I intentionally wrote 0.0 so that during addition there is no confusion. And you have to add them and you get 5,520. Yeah, I've literally added all of these myself. I have not used the calculator. And neither will you when you do the remaining sums for homework. Do not use the calculator. I wish to see all the multiplication and addition. It's such an easy chapter, but the only reason why you may lose marks is because of lack of practice. You make silly mistakes. Just imagine if you just multiplied this into 9 and you got some wrong answer, 651.5. Because of that, your addition will be wrong. Because of that, your division will be wrong and your final answer will be wrong. You'll just get what, half a mark for the entire sum, whereas you could have easily got 3 out of 3. So we have to be very attentive while multiplying and addition and division. For that you need a lot of practice. Now let's do the 6th sum, where they have asked us to do the step deviation method. If you remember, that's the longest method. So class interval is given, so obviously we'll have to find the class mark first, and after that everything remains the same. So if the class interval is 50 to 55, the class mark is 52.5. If it is 55 to 60, it will become 57.5, and so on. Once we get the values of f and x, then we know that totally there will be 5 columns. 1, 2, 3, 4, 5. By the way, there is a 6th column here because this class interval was given to us. X was not given directly to us. So first we'll find the deviation, which is always x minus a, and remember the top numbers are always negative. The assumed mean I've taken as 72.5. Yeah, there are 4 up and 3 down, but that's okay. If I have a choice between these two numbers, I would always go for the bigger number as the assumed mean. But the actual mean will be different from this, I guess. And of course, I is the difference between them, which is 5. Notice the class interval, the class width is 5. It could have been 10 also. It's not compulsorily 5 in every sum. So once you get this, you find the summation of that? Not yet. Let's go ahead. Let's simplify this further. Let's divide it by I. So we get the reduced deviation, and then we'll multiply f into t. We'll get the answers, we'll add them, and we got the answer is minus 56. Now that is definitely easier to divide with 80 compared to some huge number. So we use the usual formula, substitute all the values, and get the final answer as 69. Check, are any units mentioned? No. So you can leave it like that. Next, let's do the 7th sum. Since nothing is mentioned about the method to be used, we will use the direct method, which is the shortest method. And the numbers are also small. We are dealing with small frequencies and small class intervals. So first we have to convert this into tabulated data. This is called a histogram because the bars are touching each other. That means 15 to 25, there were 10 frequency. 25 to 35, the frequency is 20. 35 to 45, the frequency is 25. 45 to 55, the frequency is 15. And 55 to 65, the frequency is 5. So we'll write this in a tabulated manner. We'll find the class mark, which is the midpoint. 15, 25 midpoint is 20, and so on. And then we find f into x. Summation of fx upon f is the mean. Next, the 9th sum. It's similar to one sum we had done earlier, where we have to find the unknown variables f1 and f2. The mean is already given, and the sum of all frequencies is also given as 50. So the only difference in this sum is this class intervals are there, but that's okay. We can find the class mark here. The class mark will be the midpoint of 0 to 20. Midpoint is 10. The average of 0 to 20 upon 2. 20 plus 40, 60 upon 2, 30. So midpoint is 30. Once we get x and f1 is or f is already given, so we can solve ahead. Again, we're using direct method. Summation of f will be this. Multiply and get this fx, and then summation of fx. Now, summation of f according to us is f1 plus f2 plus 30. But in the question, they have given summation of frequency as 50. So using that, we get the first equation, f1 plus f2 is equal to 20, equation number 1. Second, we know that the means formula is this, but the mean is already given. And summation of fx, we found out, is this. Upon summation of f, 50, which was also given in the question. So 50 goes up, 2060 goes left, becomes subtraction. that becomes 1080. Divide the whole equation by 10 and we get the second equation as 3f1 plus 7f2 is equal to 108. And now we've got two equations in two variables which can be solved simultaneously. So I multiplied equation 1 by 7 so that I can subtract the two equations. This can be ignored and focus on 4f1, get the value of f1, substitute in equation 1, get the value of f2. So done. 10th sum. Here they have asked us to use a shortcut method. Remember, with 4 columns, but yeah, here it will be 5 columns. And what is interesting in this sum is that the class intervals are not continuous. It's 11 to 20, then it becomes 21 to 30. But what about between 20 and 21? What if somebody got 20.5 marks? Where should I include that student? Here or here? Maybe in this school they don't give half marks. They're not as generous as I am. But technically, we should always first convert the discontinuous data into continuous one. For this sum, it would not have mattered, but in the future exercises it would. So it's compulsory to write the class interval in a continuous format like this. 10.5 to 20.5, 20.5 to 30.5. See, it's continuous. So now, if a student gets 20.5 marks, in which class interval would he be placed? In this one. Yes, not in this one, no, this one. So he would be added to this frequency. Already there are 6 students. But how do we decide that? Well, first of all, what is the midpoint between 20 and 21? It's 20.5. Yeah. Between 30 and 31, it's 30.5. That means there is a gap of 0.5 in the lower class limit and the upper class limit. So let's stretch each number by 0.5. This will become 10.5, this will become 20.5. This will become 20.5 and this will become 30.5. This will be 30.5 and 40.5. 40.5 and 50.5 and so on. Note that even after doing that, the class width is exactly same. If I subtract 20.5 minus 10.5, how much is it? 10. That's the class width. What about the difference between this number and this number? It's 10. 10, difference of 10, difference of 10. The class width should be exactly same. If I were to plot a histogram for this data, obviously the class interval should be continuous as well as have the same width. The buildings can't be thinner and thicker. They have to be of the same width. This discontinuous data could never be plotted as a histogram. The buildings have to touch each other. For that it should be continuous. So that's why we should always convert the class interval into a continuous form. After that, the sum is very easy. The midpoint, what is the midpoint of this? Just this plus this upon 2. Do it. Come on, do it manually. Don't copy. It's 15.5. By the way, even if I would have found the class mark of this 11 plus 20 upon 2, it would have been the same answer, 15.5. Yeah, the midpoint won't change just because you stretched the limits to make it continuous. So once you get the values of x, that is a class marks, get an assumed mean. The middle number is this one, assumed mean. Then find the deviation, x minus a, and then do f into d, product of fd, and then add all the values. It's 70 because there are negative numbers here. And the summation of f is 50. And then the formula. This is the shortcut method, by the way, not the step deviation method. So we don't have that t out here. No need, there's no I required in this sum. And then the mean formula, substitute all the values. By the way, mean is also written as x bar. And we get the answer as 46.9. Hi students, if you found this video useful, press the like button. Also to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.